Hi, everybody, and welcome to the Code Show. And well, today is my Rust stream in English. As if you are joining today for the first time, here I do streamings on Tuesday in English, solving some Rust exercise. And then in Thursday, I do in Portuguese about Python. And there are some people already here. So, hey, João Lugão, Luiz Gustavo, Agavinik, Rust neles. Yeah. So it's about to begin, and you may note that I'm different because I joined the campaign of shave off your beard because of the mask. So if we need, I hope I will not need, but if I need to wear a mask to go out to do something, then it's gonna be very easy now without the whole beard. But maybe I'll like it. I don't know. And my friend from Eduardo, which is also a streamer here on Twitch, started yesterday, did that. So I decided to do the same. Well, that's it. So we are about to begin. Let me change to my code screen right now. Yeah, I was thinking about to remove everything, but the problem is when I was a child, when I was very young, I did something very stupid. I tried to jump over a tree, and then I got stuck with my chin, and I have a very huge scar here. So I don't like to have this scar, so I need to keep just this part. But I tested it with a mask. It's not going to be a problem. Yeah. So thank you, Carla, for hosting. Carla is my wife, and also she's a streamer. If you like games, if you like The Sims and other games that I don't know the name, you can follow her. It's a very nice stream, mostly about games. And sorry, but I don't know anything about games. Maybe one day I'll learn. Yeah, I just knew that there is some studio that's working on a Peaky Blinders game. So maybe I like very much the Peaky Blinders TV series, and if there's a game about it, maybe I will be interested. Let's see. So, well, let's get back to the code. And before I jump into what we are going to do today, let me ask you guys that are on the chat if the audio is okay, if the music is annoying. It's okay with the volume of the music. I finally have a very good player for streaming, and I will share with you. If some of you wants to be streaming, this is very nice player. I learned about it from my friend Fernando from Código Falado channel, and this player has only free music, so you can be streaming freely on YouTube, Twitch, Facebook, and there's no copyright claims, so that's very nice. Yeah, so I need to update this emoji here because I was with the bird, the full bird, but maybe I will keep like this. I don't know. I kind of like it. Yeah, it's especially if it's hot in the summer, it's very nice to have the clean face. Yeah. All right, so well, today I'm going to keep on my Rust track on Exorcism. So for those who are joining and doesn't know about it, Exorcism is a website where you have tracks for programming languages, and you can choose any track you want to be practicing. And I have chosen these languages: Bash, Go, JavaScript, Python, Rust, and TypeScript. I don't have full time to be working on all of this. I just choose it because any time I will, in future, I will jump in and try to evolve on those exercises. I'm a mentor on the Python track, and I'm helping people there to have their exercises approved. and I want to be finishing this 92 Rust exercises, because Rust is the language I'm currently learning. Yeah? So I already did 43% of the official track, the mentor track, which is 14 exercises. So I did 6. And how it works, you have this milestones exercises, which is selected by the mentors. So you need to complete one by one, like you were in a game. And then every time you complete one, you are going to unlock different exercises for you. So I have not completed everything of these bonus exercises. I'm trying first to finish the whole track, and then once I finish the track, which will be with this last exercise here, I will be getting back here and trying to do all the others. Okay, and right now I'm doing this space age exercise. I have not started. In last week, in the latest stream, I did the anagram. It was a very interesting experience, because I got mentored by a very nice guy, which is official mentor on Exercism. I don't know if he's going to join today, but it's going to be helpful if he can join, or someone else. So if you are in the chat and you know Rust, feel free to put your comments in the chat and give me some hints, because I'm still learning it and there are lots of things that I still don't know. Hey, Pokemon is also a streamer. Here I follow the channel, it's very nice. And Pokemon, today is my in English stream about Rust, and on Thursday I do in Portuguese for Python. So welcome and thank you for joining. And that's it. So before I start the exercise, let me just tell you guys something very nice, which is now I am part of the Live Coders team on Twitch. So on Twitch, there is this team of 134 live coders that are selected, and there's a whole process for you to get accepted there. And I submitted my application, and now I am part of this team. And that's very nice, because the team has lots of good stuff going on. And if you get to my channel in a time that I'm not streaming, I will be probably hosting someone else from the team. And also we are going to give raids and other stuff for each other. And also there is a website where all the streamers are gathered. And also there will be a web conference with the streamers on this team. So this is a very nice experience. People are very participating on this team. And yeah, I just joined it. I don't know a lot about it, but I'm very happy that I could join it. And looks like maybe Twitch can improve experience for live coders. Yeah, this is a gaming platform, but we hope that it becomes better for live coders, so better APIs and all that thing. So that's nice to be part. Let me test it, because if I'm alive streaming right now, I must be showing here. So you see me here at the top. So and here are other team members that are also streaming at the same time. So that's it. And you can go to the live coders, I guess, livecoders.dev, and it's going to redirect you to this same page if you want to know any of the live coders that are streaming at that time, right? And well, so let's get started. So let me check if everything is alright in the other platforms. Right now I'm streaming on Twitch, YouTube, Facebook, and Periscope at the same time. And sometimes I need to check if everything is okay. Yeah, I'm having some trouble with YouTube, but anyway, looks like everything is working, and we can just get started. Right? Yeah, my new overlay. What do you guys think about my new overlay? Yeah, this image here where I have the name, the logo, and this is a new style. Hey Bernardo, welcome to the show. Thank you for following. Yeah, This overlay was created by my wife, Carla, which is here. So if you are a streamer and you want to have a very nice overlay, Carla can create one for you. She does it professionally, so it's something she can do if you want to have good graphics, overlays, logos, and all that kind of stuff. So just reach me and I put you in contact with her. Yeah, and that's it. Cool. So let's get started with the exercise. So before I jump into the code, let's understand what we are supposed to do with this exercise here. Okay, so this is a space age, the name of the exercise, and the introduction is, given an age in seconds, we need to calculate how old someone would be on each of those planets. So for example, we know that someone who lived 1 billion seconds should be able to say they are 31.69 years old. Yeah, so that's interesting because I'm not 31, I'm 36, but I'm almost there. And based on this information, we know that how many seconds we have in a day, in a week, for example. We need to calculate how old we would be if you were in some of those planets. So we know that in Mercury, the orbital period is 0.24 Earth years. So time passes slowly in Mercury, so that's nice. And for example, if we move to Mars, it's gonna be 1.8 years. So that's that means if this person here, which has 31 in Earth, it's going to be plus 0.8. Yeah, so and we need to calculate that. So looks like it's I already done this exercise in Python, but I never implemented it in Rust, so that will be first time doing this in Rust. I have some ideas, but I'm not sure if it's going to work because we need to first look at the unit tests to be sure what we need to implement, right? So if you wonder why Pluto didn't make the cut, go watch this YouTube video. Okay, I'll try to open this YouTube video here. Let's see what's happening.
Pluto, planet or not?
Okay.
Before we can answer this question, we need to know what the word planet is for, and that takes us back to the ancient Greeks who called Mercury
Got it. So we don't have Pluto in the list because there is some kind of polemics about if it's a planet or not. Okay, not a problem. So what we are going to use here on this exercise, two very interesting things, traits. Yeah, so I love traits and I will show you guys how and why we can use it. We are going to implement the from trait and the default. I don't know why we should implement default, but okay, we can try it. And that's it. So I think it's easy to get the idea here. Do you guys think it's clear? So for example, we are going to take some amount of seconds, let's say 100 seconds, and we should say how many years that person who has lived actually we are going to take years. So for example, a person who has 30 years in Earth, we need to calculate how old the person is in Mercury, Venus, Earth, Mars, Jupiter, and all the other planets, right? This is something that we could do for dogs also, because we have some kind of table for dog age and cat age, so we could calculate how old is a dog in yeah, I think it makes sense, but let's stick with this exercise here, right? Pseudocode to explain. Yeah, I think we can, or we can just jump into the exercise. I don't know. But for example, let me just download the exercise here. Well, what I have here, a configuration. So this is my exercise. I'm going to download this new one, which is the space age. Okay, I'm going to enter in the space age folder, and in the space age folder I'm going to open my editor. Now I'm using Micro as a code editor, and that's being a very nice and easy experience. It doesn't eat my memory and it works very simple. It has no fancy features like autocomplete, IntelliSenses, and in editor debug, but it's very simple, and that's what I was looking for. So let's see, Luis, you want to see some pseudocode, right? So let's understand the problem. The problem is, let's say we have the age of a person, like for example 31. So this is the age of a person, and then we know that the person has 31 on Earth, right? And then we need to calculate how much it is in seconds, right? So if the person has 31 years, how much seconds does it? So this is the first step, I guess. So how we can get to that? So we know that we have a minute, which is 6 seconds, and we have an hour, which is minute by 6th. So we got this in an hour, and then we have a day, and a day would be an hour by 24, and then we have a year that will be day by 36.5 dot a quarter. Yeah, because we have leap years, then we have to put this fraction here. So this is going to give us how many seconds we have in a year, how many seconds we have in a day, in an hour, in a minute. Yeah, in a minute we already know that it's 60, right? So yeah, this is a cool way to handle leap years. I think it's more like an approximation. If these test cases are the same as I had in the Python exorcism, it's going to assume interval. So we shouldn't have to be precise. We can have some kind of interval. So we just handle leap years like this to be easy. Yeah, it's not precise, but it's easier to implement. So this is the first thing we need to know, right? So if we jump back to the exercise, we are going to see, for example, that on Mars, the factor is 1.8. Yeah, so if I take here Mars factor equals 1.8, right? So how can I calculate? Let me open another shell here. I think it's going to be a good idea. And I do in IPython. I always do in Python, and Python is not always nice to do to compare with Rust, because some of the operators we have in Python behave differently in Rust, but we can do calculations there, so so that's going to be easy for us to get it. So for example, traits is like interface. Yeah, that's it. It's not like a switch, it's like an interface. So for example, if I want to know how many seconds we have in a year, how would I calculate that? So I would start doing 6th plus by 6th, because this is what we have in a minute. Okay, so in a minute we have this seconds, right? And then if I want to know how many minutes we have in a day, we are going to do by 24, and this is how many seconds we have in a day. And then I can have the day by 36.5. Yeah, it's approximately this number, right? So this is for example, seconds in year. Okay, this is the number. It's a float. Yeah. So we know if the person is 31, we just need to get this, and we just need to get this number. Let me put this in a variable, seconds in a year. Not the best name, but that's it. And I do just by 31, and I know how many seconds the person lived if it's 31. I think that's the, yeah, almost there, because here it's a 31.69. I can try to reproduce that. 31.69. Yeah, so that's it. You see that this is an approximation. It's not precise, right? And I expect that the test cases are going to consider that, right? And if I want to know how many seconds this person has in Mars, I just need to multiply by the factor. So we have all the factors here, right? I think this exercise took it from some real place, right? Or maybe it's just made. I don't know. But anyway, we just need to get this. And then we are going to get this and multiply by 1.8. And then we know how many seconds this person has in Mars. So what's the next step? So this is the Mars age. I call it M age, right? So the Mars age is this. Now I should take this number and get back the years. How would I do that? I would start by dividing, and this is where things are very different in Python and Rust. Yeah, so the division and remainder operators are a little bit different, but I can get the Mars age, and I will start by splitting it in. I need to get how many years, so I would just say it's divided by this, right? Yeah, so if the person has 31 in Earth, it has 44, and but this is in seconds. Let me check. Yeah, then we need after that to calculate it back to ages, to days. Well, I think it's easier to get there to the code and try to implement there, but that's the idea. We are going to calculate durations in seconds for every period, like days, hours, years, and then we are going to calculate how by the factor of each of the planets, and then after that we have to get it back to how many years the person has. Yeah, so I don't know if we should return years or if we should return seconds. We are going to see on the test case, but I think we should return years. It would be easier if we just do 31 by 1.8 and we got this, but so that's why I think we need the seconds. So okay, let's jump to the code. It's going to be easier. All right. So I'll start by opening the test cases that we have here. The test cases, I think, are the most important part right now. I think that my font is big enough for you guys to see, right? So let's take a look at the test cases. We have, as usual, we have a function here at the top, which is support function that Exorcism gives us at the beginning of some tests. So this is the place where it's actually building the instances of the objects and comparing and treating the exceptions. So we don't need to change this function. We need to look for each of those test cases here, right? So I'll not look to that function closely, but for the test cases. And for Exorcism, we need to program based on the test case, because we are not allowed to change the test case. We should make it pass, because this is something that the mentor of the exercise is going to run on their side when he's going to approve, right? Yeah, it's just like TDD, yeah. But we already have the tests, yeah. Some people at Exorcism wrote the test for us, so we don't need to bother writing tests. So the first thing I note here is that we have the duration object here. So every time you see something in camel case or Pascal case or upper things in Rust, you can assume it's a struct, enum, or trait. So this is the three kinds of objects that we are going to name using this kind of notation. And when you see things in snake case, lowercase with underscore, then we can assume that it is functions, variables, or macros, or models, right? So it's easy to tell by the test case what's going to happen, right? Zoom, okay, a little bit of zooming. I think now it's better, right? I will be switching between those two views. Okay, so I think we need to have a duration, and the duration can be a struct or an enum. I think in this case it's going to be a struct, yeah, and a struct is just like a class, but just a data class. We are going just to define fields and attributes inside it. And this duration is going to have the from method, and we can tell by this two column here, column, that from is a static method, right? If it was a single dot here, we could say that this is an instance method, but by the two columns we can say it's a static method. And this static method is going to take a number here, yeah. So we don't know right now which is the specific type of this number. Maybe we can tell by looking here, and then we have it. It's an F64. So F64 is a float of 64 bytes. So that's what we need to be implementing on duration. And then after we create the duration object, we have this function assert being called. And we are passing the years the same way I did on the IPython shell. 3169, for example, is the Earth age. That is going to match 1 billion seconds. Yeah, approximately, not specifically. And then we are going to have this other struct here. So you see the uppercasing, the Pascal casing here. Yeah. So I'm always confused about the naming. Some people call it Pascal casing, some people call it upper camel case. If you go to the Rust documentation, you see that they name it upper camel case and not Pascal case. I don't know why, but yeah, anyway. And we need to implement a method called years during, which is going to take this object. So look, this is taking duration here, which is the instance we just created in this line. And it's taking duration as a reference. So you can tell that by this ampersand here, right? Every time you use the ampersand, you are passing this not moving, but you are passing as a reference to the function. So the function is going to receive duration as a reference. Are there bigger floats in Rust or some high level way of handling floating point like Python decimal? Yeah, I guess. I never use it, but we can try to figure out. Rust bigger float point. I'm pretty sure we have some heap allocated special pointers, which is called smart pointers. We can create, for example, a box and then put things that can be stretched there. And maybe some of those are bigger. I'm not sure if it's built-in or if you need to install from external crates. For example, this is from Diesel. Diesel is the ORM to access databases. And internally it's using big decimal, big int, and then you can, I don't know, maybe, I don't remember if we have something larger than F64. We can look here at the standard library, and we are going to have the primitive types. Maybe we have a list of primitive. No, not with this name. Let me see if there's an index here. Yeah, there's an index here. So we have but not for float, right? This is for example, this is for unsigned integer type. And for float we have only F32 and F64, and we have this I which also is an integer. Not sure if we have built-in for bigger floats, but we have smart pointers and we can build this. I guess this is something I really don't know because I never had to use it before, right? And all the books I got and tutorials yeah, so you need Nathaniel, welcome to the code show again. So Nathaniel just shared that we have big decimal crate, which is an external crate, and we need to install it. And actually I think internally it's going to mix and build some of the built-in types. It's created QRL. Let me see if there's some homepage. Sometimes homepage pointing to the docs, sometimes homepage points to the repository. And in this case, it's going to repository, then we need to go to the docs, right? So that's it. So we need to use the external crate. Actually, we can maybe implement our own types to handle this. But to save some work, we can use this external crate. Yeah. Cool. I also already learned a new thing. Thank you again, Nathaniel. Yeah, it's popular because diesel depends on it. Yeah. When I was trying to search here, I found the diesel example. It was my first result here. And yeah, if diesel is using it, it's maybe something we can rely on it. Yeah, that's it. Big decimal. It's part of diesel documentation itself. Okay, that's cool. Thank you again. So let's get back to the code. So, well, as usual, I will start by solving this first test case. And then after I make this test case to pass, I'm going to go to all the other test cases one by one. And as I already did this exercise in Python, maybe it's going to be faster today because I already know a little bit what we are supposed to do, right? So what I'm going to do right now is I'm going to open my library code. I want to save changes. No? Okay, that's it. Oh, that's interesting because I was expecting that I would need to implement everything from scratch. Yeah, I was saying that we need this duration, which may be a struct or enum and all these other things. But looks like we have some implementation here for us to take a look. So that's nice. This boilerplate helps a lot when we are doing these exercises because sometimes we may be trying to think about how we are going to structure things, and in this way we can just focus on solving the problem, the calculations, and not on the structure of the code. So that's nice. I don't know if you are involved on these examples, Nathaniel, but if you are, thank you for having very good examples in Exorcism. Yeah, I know that there is a repository for the Exorcism where the things are, the exercises are store it. I just don't remember where it's. Somewhere here. There's a GitHub here. And all the exercises boilerplates are here. Yeah, so we have, maybe there is a Rust repository here somewhere. Yeah, here. And then all the exercises and test cases are inside this big repository. That's nice. We can, for example, take those exercises, clone it, and keep implementing if we don't want to use the official track. Yeah, but I recommend everyone to be registering to the track and doing everything in the mentor mode. Even if you have to wait some time to get your exercise mentor, it's a very nice experience, right? And it gives us the sense of achievement. Yeah, so that's a very nice thing. We can achieve some milestones, and it's a motivation to keep doing it. Yeah, so let's go. What we are going to do first, here we have duration, well, which has an implementation of from. From is a trait to convert objects from one type to another. And we have Earth, which is a planet, which is going to have years during method, which is also a static method. And we can see a pattern here, because Earth, Mercury, Venus, all of them has the same notation, the same method. So I think the code is going to be very lean. Yeah. Okay, so first thing we need to do, I think I would define some constants, maybe. What do you guys think? Maybe I'm going to get the code below is a stub, just enough to satisfy the compiler. In order to pass the test, you can add or change. Okay, so first thing I do is going to test it, right? So let me just run cargo test here. And we want to see the test failing, because you can never trust in a test that you don't see failing, right? So all the tests are ignored except by one, and we see this is failing, so that's amazing. Then we can get back to the code, and what I'm going to do is to define a constant here, because I think I need to be storing the how many seconds we have in a year at Earth, right? I should be I should have copied that. I forgot about it. I'll do the calculation again here in another terminal very quickly, just to have this number, so we know that we have, for example, I did it. If you guys remember, I just don't want to Google it, but okay, let's do that very first. So we have 60 seconds by 24 hours, and this 24 hours by 365 dot. So this is something like this, right? Oh, it's in the README. Oh, I'm very... I should have saw in the README. Where is it? Okay, it's here. Thank you again. Yeah, always read the README, and then you are going to save your time. So, but my calculation was right. Okay, this is the very same number we have here. Okay, so I'm going to store it in a constant, which I'm going to call Earth year. Let me call it very explicitly. Let me close this terminal here. I don't think I'm going to use it again. So seconds in year. So to store that, I need F64, and it's going to be this number. And just to be a little bit better, I can separate it with underscores. I guess that's it. Actually, I think I need... No, I think that's it, right? That's strange, because my editor should be formatting this part in different color, but maybe it's not working. but okay. So this is F64. How many seconds we have in the year? 31 million seconds. Compile error right now. Yeah. Okay, let's see. I like to see the compile errors. Make test. Okay, failed. No rule for test. Oh, stupid. I used make test instead of cargo test. Yeah, now it is. Okay. Expected. Okay, you're right. Compile error because what I created here was an integer. Yeah, because I don't have the point. Or I create using that point here, or I just can finish with F64, right? And then when I use this suffix, I can force the compiler to be transforming this value to a float. That's it. Cargo test, and that's it, right? Test is still failing, but my constant is created, and just this warning here is just because it's never used. Yeah. And Nathaniel has a very good eye to catch my errors here. Thank you again. So, okay. So I have the seconds in the year, and now I have the struct duration, which is has no data in it. What I need to store in the duration? That's the first question. I need to store in the duration. Let me read the test cases again. So I'm going to create duration here. Duration is going to be created from a number. In this case, this number is an integer, right? And when I create this from the number, I'm going to store here duration. And when I'm going to access this value, it's going to be passed as the second element here, the second argument, which is received here in the actual. The actual is F64. F64 expected, right? So it's just a number. So I have some options here. Okay, so I can implement this duration as field struct, like having seconds as F64. But maybe it's going to be easier to implement this as a Topo Struct. I guess it's better, which is going to hold only a single value of a float, right? So I guess this is the whole implementation I need for this struct. Just making it hold F64, and then here when the from method is going to be called, I just need to convert this integer to this format here, and then I need to do this inside here, right? So let me remove this from here and think about the from. So first, for those who are in the chat and doesn't know about how this works in Rust, I'll try to explain, and if I do something wrong, please anyone correct me. In Rust we have this concept of traits, right? So this duration here is an object, data object, data structure, and this data structure holds only data, right? It doesn't hold any kind of behavior. So it's a little bit different from other languages where we have object orientation and classes. So here we put only data. This form of struct is called a Topo Struct, where we can have values. I could do something like this. For example, the struct is going to hold F64 plus a string. I can have multiple things inside this Topo Struct. This number here, for example, is going to be located in the index 0 of the tuple, and if I put other things, we are going to increase the index. And also, as I was showing, I can have fields, just like data classes. And as we have only data, we can create implementations. So I could come here and say imp duration, And inside this imp block, I can create functions. So I can say, for example, thing, and this thing can be a method that's going to return something, anything, and then I implement what is the actual logic of this method, right? And this thing here inside can be a static method, like I was showing you guys here. We call static methods with two column, in the name, so we know it's static. And we can also have instance methods that we depend on the instance of the object, and for that we receive a reference from of self, lowercase here. So if the method is implemented with self as the first argument, we call it an instance method. If it's not implemented with self, we call it a static method. So for those who are from Python, this is very usual because it's the same thing. And also the imply blocks can have associated types. We can put types here and define types in all other things. So that's the idea. And traits. So this is, if I was going to do the implementation of functions over duration, I would do something like this. But as the exercise says, I need to use the trait. And trait is like an interface. So not exactly, but it's like an interface, because in Rust we don't have object orientation inheritance. So we implement traits. Yeah, we implement interfaces. But yeah, just the same idea. So we have a common trait called from that we can implement over any object. And what the from does is that it can convert one type to another. Yeah, so we need to, inside this from method, we need to implement how the conversion is going to be implemented. So also, for those who are Python programmers, you are going to see similarities of traits with what in Python we call dunder methods. So if you created, for example, a method called iter in Python to turn an object to an iterator, if you create an exit, enter, those kind of special methods, you are giving object special behavior based on the implementation of those methods. And traits are something like this. We can give this object here, the struct, some special implementation based on traits. Yeah, and the language itself uses some traits. For example, when we want to print something to the terminal, we need to have the display trait implemented. If you want to debug something, we need to have this debug. You can see here at the top there is a derived debug. So debug is a built-in trait for printing debug messages to the terminal, and so on. So trait is like an interface, and then inside this trait from, we need to implement, as I can see from the test case, something that will take an integer. Yeah, because I'm passing integer here. Every time here I'm passing integer, so it's going to take integer, and we can see here that it's bounded to unassigned 64. So this number is going to be converted to the the float 64 we have in the object. So how can we do that? I don't know. I think it's clear that we need to return self. Then you can see self here is uppercase. So this self is related to the struct itself, to the object itself. So again, if you are from Python, this is the same as CLS when we have class methods there. So we need to return an instance of self, which is duration, right? So here we can just return a self, which points to duration, and then we need to pass inside this, but not this way, because it's a tuple, and duration is going to receive the integer converted to float, which is easy because we can do just s, which is the seconds, as f64, I guess, right? Because this s is something that we'll call the from trait from integer to f64. So if you look to the implementation of integers, the integer has a from trait implemented, and that from trait has a way to convert to f64. We can also check it, right? So doc.rustlang.org standard. I guess I can come here and see the implementation of u64. I think I can have here standard u64, and somewhere here I will have the traits that is implemented, I guess. Keywords. Oh, looks like I don't have it. Primitive types, well, models, where can I find it? Just as a matter of curiosity, right? Yeah, that's here. Trait implementations, which is somewhere here. Try from step. Somewhere here we have from. So in our case, we are telling it to do s, which is an integer, as f64. So we should have from integer. Oh, that's actually the opposite. We need to get from f64, right? And it can be created from u64 f32. Well, I don't know, but it's something like this. You see that this type has this implementation, converts u32 to f64, and we can actually see the source code, and this is the implementation, right? And you see that it's very simple. It's just using the as again to fire I don't know. Okay, but doesn't matter, just a curiosity. So what we are doing here, we are creating our own type duration, and we are ensuring that the integer that is passed to the from is stored as f64, right? Hi Neil, thank you for your yes on the chat. Okay, so I think that this is the whole implementation we need for the duration object. Store f64 has the from to convert, so we can do duration as, for example, we can have duration from and pass an integer, or maybe we can have the bounds to have integer as duration and get the duration object back. Not sure, but we can try it if it's needed. So the next step is we implemented duration that was already there in the boilerplate. We implemented the from method, which receives an integer and converts. And now we are going to pass the reference of the duration to earth. And earth is going to receive the duration as a reference in a method called years during. And let me see here what's happening. When I get this earth years during return, I'm expecting it to get me back in f64, right? What is expected, so it's all going to be floats, right? So let's get back here and do the implementation of this method. So I have a trait planet, and you can see that this is not a struct planet. It's a trait that we are going to implement for every planet we create. And this is telling me have years during, and I'm going to Let me try to build it just to see if I have some syntax errors or something. Okay. Yeah, the compiler passed, so the code is okay. We just have the test still failing because it's missing implementation. So that's nice. I'm going to remove it, and let's now do the ears during object method, right? Let me just see who else is on the chat. I will see some familiar faces here. Okay, some people at YouTube, Twitch. Nice. That's okay. So everyone is following the idea here of converting from one type to another in the implementation. If you guys have any kind of hints or question. Yep, nice. If you have questions, you can ask me. Probably I will not know the answer, but we have very smart people here on the chat that can help us. Yeah. So thank you. Okay, so let's go to the ears during. What can we do with this ears during? So this is a trait, right? It's not the proper struct. It's not going to be a planet itself, right? Because planets are implemented here below. It's an interface. It's more like an abstract thing that we are going to apply for each of other objects. So this method ears during should be very generic, not in terms of types, because we are going to use only the duration and F64, but the implementation, the behavior should be very generic, based on each of those planets. And well, maybe we need to do some decision here, because if we look to the exercise, you see that for each planet we have a factor. So Mercury 0.24 and so on. So we need to take those, for example, Mercury has this factor for us to calculate where to store this. So that's the thing. So one idea would be coming here in the struct in itself, create a field called factor, and then not here, right? So the factor would be a F64. So we will need to copy the same thing here to all the other planets we are going to create, but I think it's going to be very repetitive. We are going to have multiple the same code copied in many places. I don't think I like this. And then when we create here, let's see the tests, yeah, because the test is going to tell us what's going to happen, right? Here Earth is going to be calling ears during, which is a static method. So we don't have an instance of Earth. We just have the struct holding the method, and everything is going to happen in the static method. We are never having an instance of Earth, Mercury, and so on. So that's interesting. Okay, so that's not going to work. We need our struct to be very lean, like this. We are not changing it. And I don't get why we... Well, actually I get. We could use this unit. I don't know if I remember correctly. It's called a unit struct. It doesn't have any method, data, or implementation, just a name we create, just a symbol. And then we can put implementations over it. So everything we are going to be storing should be stored in the implementation. Okay, so my idea is to come here in the trait and create a constant called factor. And this constant is going to be F64. Okay. So when we implement the planet for Mercury, we are going to need to pass here what is the factor for Mercury, for example. and then we can pass it directly here, I guess. But I will need to say the type, right? And then I'll just copy this code for every other implementation, and I will change the factor dynamically. And then here I have the associative constant inside the trait itself. Okay, I think it may work, and we can just now try to implement this ear during. That's why I was telling that maybe we are going to finish very soon this exercise, and maybe we can jump to the next one, because once we solve this ears during, I think that all the tests is going to pass, I guess, right? So how can we calculate the ears during, for example, for Mercury? Let me see if I copied the right thing. Yes, Mercury. How can we make this first thing passing? For Earth first, since it, oh yeah, nice idea. So our first test is Earth, which is nice. Okay, you're right. Let's do for Earth first. We'll remove it from here and do for Earth first. And the factor for Earth is easy because it's just 1, right? 1.0. Earth has the same factor as Earth, which we are going to use this constant here above. So, okay. And then now let's go to the proper implementation. In this case, I can just do like I have duration, which I'm going to receive here. And to take the float, which is stored inside duration, I need to use the index because it's a tuple struct. So I'm going to take the D0, right? So D0 is going to take F64. And as I was telling before, if I have, for example, an integer 32, this integer was going to be on the D1 and so on, D.1. And that's very odd in Rust, because sometimes we expected we could do like this, but this is not working. We need to use the dot notation to access the indexes. Yeah, so we are going to take the first one, which is the actual duration in seconds, right? Okay, so D0 for this test here is getting 1 billion. So we are taking 1 billion, and we need to return the years. So the calculation would be taking 1 billion seconds, dividing it by the days in the year. Let me think. Oh, actually just dividing it by the factor, right? The factor is here. So if I take it and divide, so but to access the factor, I also need to do like this, self factor, right? So factor for Earth is going to be 1.0. Okay. And then years during receiving a duration holding 1 billion as a float, as an integer. No, not as an integer, as a float, because it's converted here on the from. I'm gonna take D0, which is this float, and I'm going to divide it by the factor. The factor is going to be 1.0 for Earth. And this 1.0 for Earth is going to return in seconds, not in days. I'm not sure. So this is going to return in seconds, but here I have days. So maybe this assert in delta is doing some calculation. Let me see. I take the diff as expected minus actual ABS 001. Why is this 3169? Is this first argument years, I guess, because we are telling that if the person lived 1 billion seconds, it's the same as living 3169 years, right? In this case, the assert is going to take 3169 here on expected, and it's going to subtract the actual, and the actual also should be in years. So how can I get the years without... I need to use the seconds in year somewhere. Yeah, that's what I'm missing. And where I'm missing it? Years during... I don't know. Years during is taking the... I think it's okay because the years during is returning d0 divided by 1.0, which is going to be the same, but somewhere I need to transform it. And maybe I need to do that when I do this constant here, or here inside. Yeah, I need to do this here. So actually this factor here, it's not only 1.0, right? It should be the seconds in year multiplied by 1.0. Yeah, that's the thing. So here I get the seconds, which my editor is not helping a lot. Seconds in year multiplied. Yeah, now it makes more sense. Because, for example, for Earth, I'm going to take seconds in year, which is all those number here, and I'm going to multiply it by 1.0. That's fine. And then I'm going to take this as the factor. Help me think, people. I don't know. Seconds in year. I don't like the name of this variable, right? The seconds in year is for Earth, so it's being called Earth factor. That's what, just to make things easier. So it's Earth factor, and then I will get the Earth factor here. Okay, and Earth factor multiplied by 1.0. D, yeah, we are doing the factor divided by D here, right? D0 divided by factor. But this factor that we have in the trait is variable. For every implementation, we are doing the Earth right now. So for every implementation, we are going to have a different factor. So the factor is going to be the Earth factor multiplied by something. Yeah, that's what we did on the terminal before. We did, for example, Mars is how many seconds we have in Earth by 1.8. So for Earth is 1.0. For Mercury, it's gonna be 0.28. And then we have the factor in seconds. What I'm confused about is that I need to return it as days. Yeah. Okay, so actually let's, yeah, I'm doing just for Earth. So I'm implementing just Earth here, right? And Earth is implemented here. The trait is going to receive this factor by the implementation here, right? This associative constant is going to be replaced and going to be called here. Okay, and Okay, let me try to run it. Cargo test. Okay, so, it's going to say that I'm missing the implementation. So what can I do to make it happen without having the missing implementation? Is to maybe comment. Not sure, but I'll try to comment everything out. I don't know if the test is going to fail, but we're gonna see. Don't have the impli anymore. Cargo test again, and it's failing. Function or associative item not found in the space. Yeah, because it's not going to find things that I just commented out. Okay, how can I do that? How can I run just Earth? Let me put Earth as the first one here, just to make things easier. Just set the factor to 1 for now. Okay, you mean the factor here, right? Okay, I get your idea. For now, I comment this code out, and I do d0 divided by 1 directly, just to see it passing. Oh, for each planet. Okay. I was thinking about going further and try to not repeat the code a lot by writing some kind of macro to create all these things for me. I don't know, it makes sense, but just to start, I will do what you were telling, which is create a factor of 1 for everything here, right? So here I'm going to have a factor of 1.0. And let's do that for everything. Very good idea, because the test is not going to run anyway. So that's it. Cool. Cargo test. Okay. Whoa, that's passing. Yeah, I was not expecting it to pass. Why is that passing? So we get Earth passing. Okay. Okay, so Earth is passing with this implementation. And now we need to understand what's happening here. And then after that, we try to change all the factors and see what's going on. So let's look at the test. So test is creating a duration from integer. So when we call it, we are creating an instance of this duration here. That's going to be returned by this from. And this is taking the integer as s, and then it's going to return the duration tuple having a float inside it. So okay, then we are passing 3169. That's where I'm not understanding, because from now I have not converted anything to days, right? I'm just using seconds, but this method is passing as years. So I have 31 years. I don't get where it is getting converted to seconds here in this assert delta. So I have the expected Earth factor converts to year. Earth factor is here, right? It's going to be how many seconds we have in a year. Okay, and Earth factor is making it multiplying by 1.0, which is going to be the same, right? 31. Okay, now I think I get it, because this float is what we are going to have from this integer. Okay, Earth factor to something better. What kind of factor is it? Yeah, you're right. Maybe the name I was using before was better, right? Because this is actually how many seconds we have in Earth year. So if I try to rename it, let's do this. I have how many? Just twice, 2, right? Yeah. So I'm going to rename back to seconds in a year. Oh. Seconds in a year, right? Okay, so how much seconds in a year? Seconds in Earth year, yeah, let's be more precise. Earth year. Okay, seconds in. Oh, my multi cursor hasn't worked. Why not? I spent some time last week writing some plugins to this micro editor using Lua, and one of the plugins I was working on is the multi cursor. For example, I can press here, if I have my cursor in the duration word, I can press Alt N and it's going to select all the and create multiple cursors for me here. And for some reason it's not working when I have underscore, I guess. Let me see. No, it's working. I think maybe, I don't know. Yeah. But anyway, let's go in. Test it. Okay. Now I understood. Thank you, João. Seconds in a year is going to be converted this integer to a float, which is going to be in the range for 3169 here when I do this calculation for the difference. So I don't have to bother. So, well, I think this thing is resolved, right? I guess the thing is resolved. Let's do something which is taking all the things from here to there. So I'll just copy and I will actually, what I'm going to do here is I need to copy and paste here. I would like to use my multiple cursors here to try to automatize it, but I don't know if I'm able to reuse these names in a very good way and maybe delete everything that matches it. Then I have Mercury. All the names are already in uppercase. And simply planet for Mercury, so it's gonna be like this. And I use the power of multiple cursors here to do simply planet for Mercury. Whoa, something wrong. Now I'm stuck here. not the best idea. Okay, I just want to reuse some code. So what I can do is to take this and go to there, remove. Okay, so Earth is going to be just 1.0. I already have it. Okay. And this are the what I want here. Oh, cool. Looks like my idea is going to work. Copy and paste, yeah, it's a copy and paste with some struggling a little bit with my editor. I'm trying to get used to this editor. Well, planet Mercury, right? So now here I'm going to, no matches found. Oh, looks like my multi cursor needs more than one character to match, to have matches. It's not matching over single word, a bug that I should be resolving. So I will need to copy. What I can do to have my life easier and also learn a little bit more about the editor is to do like this and put my semicolon here. But anyway, I want to create a macro for that. We are going to create a macro to automatize that after. Anyway, because it's too much repetition in the same code. So, and what I'm going to do here, I'm just copying this, and now it's copy paste, right? So copy paste it here, copy paste here. Whoa. Here. I need to fix that bug so I can have multiple cursors in a single character. And then I'm save and everything is formatted. Cool. And then I can, well, where I was. The problem is that I'm going from Mercury to Neptune. So everything from here to Earth, I can just delete. I did something wrong. Yeah, because I need seconds in here. Okay, I can just copy it and put there. No problem. Copy paste is not the best idea because we may miss things like this. I just missed it. Mercury to Neptune and Earth is something I already have there. Okay, so I need this calculation inside. It's not just the factor, but I need to multiply by the seconds. So it's going to be like this. Just move it to the function itself. You mean here when I'm using... Okay, you were right. Well, but if I'm going to create a macro... Okay, so I'll do what you are saying, and then after we can see if it's going to work in a macro. So what I need to do is second... It's the opposite, right? So it's this. And I'm not sure, but maybe I need some parentheses here. You mean like this? Let me check. Okay, the first one passed, and now I'm doing all the ignored, right? Okay, we have it working. So all the tests are passing, just 7 tests. So wow, that's great. Let me remove this comment here. Cargo clippy, okay. Cargo clippy. All right. Good idea. So what's the problem? The problem is it's telling us to use underscore to divide so it's more readable, right? Long literal needs separators. Okay, can do that. I don't know if I can do that automatically. Maybe I know that I'm already running, every time I save, I'm running cargo FMT to format for me. But I know that we have cargo fix, right? I never used that. Let me try. I don't know if I have it. Cargo fix. Error, the work director of this package has uncommitted changes. Okay. I can run cargo fix only if I commit. So anyway, I'm not using it. But I know that cargo fix can apply that automatically, right? I was just curious about it. Okay. Let me copy paste your command. Unstable options. This -z is what's going to skip the state of Git repository. The Z flag is only accepted on the nightly channel. Yeah, I'm on the stable. Yeah. Okay, anyway, no problem. I will be doing that one by one. No problem. Let me see the output of Clippy again. Okay, got it. I will just do not like this. There will be 6 to 1 like this, not like this. Oh. Cargo test include ignored Z unstable options. Ignored and unignored. Okay. Some advanced which are going on in this command. Yeah, I agree. Yeah. I don't understand all the parameters of this command also. Let's just see here. How is the separator supposed to be used? Tree. I'm doing all by the tree. Cool. Cargo tests include ignored underscore are reversed in decimals. Okay. Let me try this command. Z unstable options. To run all tests include ignored and but when I run dash ignore like this, I was being running here. Okay, if I do like this, it's going to include ignored and unignored, right? So if I do like this, I have, oh no, I don't have a earth here, right? I was not aware about that. So let me try your yeah, so now I have earth. Cool, thank you. I was expecting it would include everything. Yeah. And why I need these unstable options here? Include ignored is going to include, but unstable options is needed in this example, or I can do just like this. Oh, okay. Test failed to rerun. Include ignore flag is only accepted in the nightly. Okay. Got it. Yeah, I'm not currently using nightly for these exercises. Do you think it's best to do exorcism stuff on nightly? Because I can just change here. I have it, but I'm not using. Okay. Thank you. So right, I need to change. I really would like to clip to do this automatically for me, right? To get this thing formatted for me. Yeah, I have nightly installed. So you say that I can do cargo plus nightly directly like this. Okay. And then I can use fix. But also I'm going to have the same problem. And then I need to use the dash Z that you showed here in the command. Let me say cargo fix dash Z unstable options Clippy. Yeah, I'll need to commit anyway. Okay, let's do all by hand because it's going to be easier, and I guess it's just like this. But in this case, I don't need to be using the F64 here, I guess, because I used it in this first one, right? In this case, I already have the 0 and I don't need it, right? Hello, dirty. Okay. Oh, okay. Let me try again. Follow dirty. Whoa, it's running. Let's see what's happening here. Enter to continue. Oh, it is reloaded. Thank you so much. So that's it. I'm going to copy this command and save it somewhere because I very like it. Let me save it on some of my snippets here. Cool. Okay, so now I can go to the cargo test again. Include ignored. Well, okay. Okay, so that's it. Oh, yeah, and I can run cargo clip again, right? Cargo clippy, and everything is fine. So what I'm going to do right now, is there something else I can improve in this exercise? Do you guys think something? Any suggestion? Any question? An idea? I will close this test case and not save it, right? Okay. Yeah. You could do a macro, but it's not required. Yeah, maybe I'll submit as it is, and then I will try the macro just for trying, and I have some spare time for this string. I think I can do the macro very quickly. If I remember correctly, I would create a macro to automatize all that we have from the line 19 to the end of the file. So all this code I selected here is going to be replaced by macro, and macro is going to automatically do this for us because it's all the same pattern. Yeah, so all this code is doing the same thing. We are just changing these factors. Then we can it's a good candidate for a macro, right? Let me submit it first, and then I will do that. So what I'm going to do is Exorcism, submit, and also I'm going to, oh, I have lots of stuff that I don't want here. I have my PyCache. Why I have my PyCache inside the Rust program? Yeah, that's strange. I was doing on the Python track some things using MyPy, but it was not on the Rust thing. So I don't know why I have this backup file. I think I can just remove it. Anagram is the one we did last stream. So I will remove this one. My PyCache. Also, I will remove the lib backup. Okay, and then I will add here, let me see, it's modified. Hello world in Go is modified. I modified it, I don't remember. I think yes, I think I was playing with some Go example for doing some tricks in my editor, and then I modified this Go thing here. Yeah, so I will need to check what I changed. Git diff, what I did here in the Go example. I just removed this. I think it's not supposed to have it, and here we got some, I don't know why I did this, static A, and created a single test. Wow, I don't want this to be committed. So well, I'm going to do is checkout anagram let me see. I have all these files to be included, but it's not included yet because it's just new. So what I can do is just a git stash, right? It's better. And then if I do a stash, now I have only my files, and I can get git add this thing, and that's it. That's what I'm going to commit. So first iteration of space age in Rust. Okay, so that's it. Exercise is submitted, and now I can get back to create the macros. Let me just confirm if it's submitted. It's taking some time to load. In those days of quarantine, lots of people using the same network, the whole city and the building, and sometimes it's very slow. I don't know. Yeah, it's okay for the string. It's okay. So yeah, the exercise is there, and let me just check if everything is okay with the string, because else I will be talking here and you guys are not. Okay, I have some people still there. Cool. Let's do the macro, and let me remember how to do that. So which code we are going to, oh, I'm not on the editor, I'm here. So okay, I want to replace all this code which is repetition with a macro which is going to automate this for us. So the first step is going to be comment this out. So from here down, I don't want to create this struct in this implementation by hand. I want to create a macro for doing that for me. And I start by using macro rules, which is a macro, which is going to create new macro. And I can give a name for that macro. Which name can I give? This macro is going to create a new struct for each of the planets, and also is going to have the implementation for each of the planets. So I can call it planet. Yeah, thank you. Good idea. So we called planet. And now the proper syntax here, I don't remember if it's like this or if it's parentheses, but I think it's like this. Oh, doesn't matter. I think macros can handle both, right? I can use any one and it's going to work. I'm not sure. But okay, I have a macro called planet, and inside the macro I need to do a pattern match, right? So every pattern I have here, I need to match inside the first arm here. And if I remember correctly, in the macro we have only one arm for the pattern match. So it's going to be the same. For example, if I have a match over a number like this, here I can have the pattern, and here I have the arm that's going to resolve the code for that number, and then I can have multiple patterns resolving to different stuff. And in the macro it's the same thing, but as far as I understood, we can have only one pattern. Formatting, I got errors in the formatter. No problem, I got errors because the syntax is wrong. And so I need to create a pattern here, and then this pattern that I'm going to create here, it's going to resolve to a block of code. And this block of code is what is actually being executed by the macro. Yeah? So it's something like this. So anything that is matching inside this parenthesis is going to execute anything that is inside this code block. So here I can name this stuff. How I want to use the macro is the first thing I need to be thinking, because by the use I'm going to implement the pattern there. So if the planet is going to be used like this by passing the it should be like a function, right? So like this, and I'm going to pass a name for a planet, for example Mercury. So this is the first thing I'm going to pass to the macro, a name. And also I'm going to pass the factor, right? This number here directly. So that's what I want to call. And when I call this macro, I want it to create the proper object and implementation inside this block. So here I need to create variables to be capturing those things. So I will have something called name, and inside the macro rules we have some special types, right? Macro shouldn't be a string here. Yeah, actually in the macro it can be any symbol. There are macros that can do, for example, HTML. They're also macros that you can just come here and do, for example, div table, and you just do like this. So it's very wild. You can do anything you want inside the macro, as long as your implementation can handle this pattern and parse it. So if you implement some HTML parser here, you can just write HTML inside it. There is a macro that, for example, Helix is a crate to use Ruby inside Rust, and then inside Helix you can create Ruby code. Yeah, it's pretty limited. More powerful is to use proc macros. Yeah, I never used proc macros. I created only simple macros. I know about proc macros, but never implemented. But I think for this example, I can go with just simple macros, right? I don't need to use those proc macros. Maybe this is something I'm going to explore in another. Yeah, okay, nice. But for example, to do HTML and that kind of stuff, I can use macros like this. If I can get in the pattern, I can get the HTML code and parse it. Because the example I was doing from the book, I think Rust in Action, is a macro where you put some markdown code inside it, for example a title, list, and then you get this from inside a macro called markdown, and then your implementation is going to take this and transform to markdown inside it. And if I remember correctly, it was not using proc macros. Yeah, but anyway, you can do lots of stuff inside macros, and there's this one we can write Ruby code inside Rust. The one for HTML and markdown are also very interesting, and I have seen macros mostly for it. Actually, and for Lisp, there is a macro which is a Lisp machine inside Rust where you can evaluate stuff. I don't know if it has any useful, but yeah, derive is a macro. Okay, so here when we have this derive debug, it's a macro, right? So when we call derive debug, this macro is resolving the implementation of the bug for us, copying the code and putting that in our attributes and macros. Okay, so in the tests, yeah, every test attribute is also macros. Okay, very cool. Yeah, I like this idea, because for example in Python I'm doing very sometimes I do some meta programming, and we can in Python create classes, functions in runtime, and that's very powerful, but it's very dangerous because it's created at runtime and not in a pre-compilation. And what I like about macros is that it's created in the pre-compilation. So the compiler is going to receive the same code I have here. So as I have been writing it down, the compiler is going to receive the same thing. Yeah. So, okay, so inside the macro, the pattern for the macro, I have some types, which I think are special types inside there. Well, I think we can. I was having some macro by example or something like this. Yeah, macro by example. This link, I'm gonna paste it to the chat because it's a very good reference for those who are interested in writing macros. And this is what I was looking for. So you have the identifier, which you can get, which is the name of the macro. And inside you have this macro specs here. Look, it's the fragment types. It's just like types, but for the fragments. So for example, you have this ident for identity, and in this ident you can get this Mercury, for example, as a symbol, and you get this if I remember correctly, block is what we are going to get, this what is passing there, or no, block is what is getting when we use brackets, right? When you use parentheses, we have the ident, and we have I don't know if it's item or expression, literal, lifetime. Okay, but anyway, we can capture the specs on the pattern, right? So this specification is for the pattern of the macro. And for this example, the name is going to be the type, the spec ident. It's going to identify. Then I can transform it to uppercase, or better, I can just pass uppercase here to be easier. So now I get the ident, and I'm not sure what more can I do. I think I can capture this number here, right? Which is the factor. So I use the same thing like this. And if I'm not wrong here, I'm going to capture the expression or the block. I'm gonna try with the block, which is going to be the second thing here, but not sure if it's expression or block. Okay, so I'm passing just two things separated by comma. So you see here, I have parentheses, the same way I have when I calling the macro. And I have a comma. I could use anything. I could use, for example, a pipe here, and then here I can put a pipe. I don't know if it's called pipe everywhere, but I call it pipe. I can use dash. I don't know. We can, I suppose we can use anything to create the macros, but it's common to use commas, I guess. And this call for Mercury with this factor is going to match this call here in this first arm. And then whenever we want to create with this, we are going to create inside it, right? And that's it. Now what we are going to do, we are going to copy paste some code, because here I'm going to create the struct, and I'm going to create the implementation for the struct. And now we start replacing the proper things with the variables we captured here. So the first variable we have is name. So instead of calling the struct Mercury, we are calling the thing name. And instead of using factor as a variable there, as the literal, yeah, we are going to put factor here, right? And actually this planet here maybe can be also part. Oh, it doesn't matter, because the name of the macro is a red planet, so it can be hard coded here. What more? I don't need this space here. And then I can create Mercury, and I can create every other thing, I guess, right? I need to call the macro for each of the planets, or I would need to create a new arm. So that's where maybe it would be nice to have another pattern here, maybe receiving, for example, a vector of planets and things and creating all the things in a book. Don't know if it's possible, but okay. I'll just use lots of copy pastes here. Mars, Jupiter, Saturn, and Uranus, and Neptune. And now I need to change I should have done this I should have saved it, like for example a table, and called the macro inside the for loop, maybe. Let's go with this, and let's copy and paste everything. Whoa. Oh, Earth is 1.0. Earth 1.0. Mercury is right. Venus is right. Now I got Mars 1.8. Jupiter. Saturn. I would have to write a macro to do the for loop, you mean? I can't call the same macro inside the for loop? 160. I think it's okay, right? Yeah. You can't have a top level for loop. Okay, you're right. So what I would need to do is, if I want to don't repeat this in this way, I should be doing, for example, a new macro like planets in bulk. And then inside this planets in bulk, I wrote it wrong. I would pass all the things inside a vector or anything like this. And then when I call the planets in bulk, it's going to call the other macro and create things for me, right? But for this example, I think this is okay, right? So let's compare. We have here all the 8 planets and 8 implementations having 3. So we have 30 lines of code, right? And here we have just these lines of code. I like it. I know macros looks like some kind of black magic. You have lots of witchery running, and especially if the macro implementation is outside your own code in an external crate, you don't know exactly what's happening. But I think it's good because you can reuse a lot of code. There are people that doesn't like to have macros like this. Cargo expand. Maybe I already have cargo expand. I'm not sure. Then I can see what it expands. Okay, so let me just test first, right? Cargo test. Oh, no rules expected for this token in macro call. Maybe it's not block, right? Let me see. Cargo test. Oh, look at this. It received Neptune without errors. So that's ident. And no rules expected for this token, which is it's not a block, right? Okay, a block is just if it was surrounded by a block. It's an expression. That's sure, because here I can pass any expression, and any type in Rust is like it's just an expression. So that's the problem. When I look at here, I was thinking about a block, but it was actually expression. Let's go there and test it again. Whoa, yeah, that's good. And I forgot to run the ignored. You said include ignored, right? Include ignored. Let me find that command again. I miss it. Ignored. And I need the Z unstable options for that to work. Unstable options. Yeah, that's it. Okay, so everything is passing. And you say that I can install cargo install cargo expand, or is it a component for me to install using add component? I think I already have it, but let me check. Cargo expand. It's a sub command, so maybe I can install it. Cargo expand. Cargo installer. Okay, so that's the way to install it. And we lost the music. I don't know why, but this music player is crashing sometimes. It's very nice player, but it's crashing, and I guess that it's crashing because I don't have a premium account. So maybe it's playing 10 or some more music, and then it's crashing, trying to have me to buy a premium account for it. And maybe I will buy it because it's good and it's working for YouTube also. So. Cool. Cargo could not find cargo expand doesn't exist, right? It's expand. And I was thinking I had it installed, but I can run it directly. Rusty profile checks unstable pre-expanded or just cargo expand. It takes some time to install everything because there's a lot of dependencies, but that's the price to pay, right? And we are just in the middle of the process. It's a lot of things, yeah. I know that there are some things that are very small and in a separate crate, like colors. Having regular expressions also is in a separate crate. It's also using clap. The other problem is that my internet connection is not very helpful today, so it's going to take some time, but Almost done. And we are very close to the end of this stream, and today I will not forget to give a raid to some other channel, so I need to be selecting some other channel that I follow to raid. I don't know who is online now. Let me check. Yeah, there are some people online here. And what I'm going to do is maybe I'm going to take the channel that has lower amount of viewers and do this after I... That's the first time I'm going to use this actually on Twitch. Yeah, never did that before. And also the problem of doing the installing this while I'm streaming is that I'm going to have a very high load on download, and also while I'm doing upload at the same time, so that's a problem. But must be interesting to see what Rust is expanding to. Almost there. Check it again. It looks pretty nice now, the connection. Are you guys still there? I'm thinking about having some different stuff here in the chat, like some commands to add some interaction, like sounds. I don't know, thinking about it. But people are complaining that when I'm doing streaming and have some sounds jumping on the screen, it's going to distract from the actual code. But I'm seeing other streamers that are using lots of things, so you see on the screen lots of stuff in panels and things. I still don't know if it's a good idea, if it gives some value to the stream, or if I should focus only on the code. That's something I've been thinking. If I put too many things here, maybe it's going to be distracting, yeah. Oh my god, it's taking so long. Let me check what people are talking about on Telegram. Yeah, taking so long. I don't know. Sometimes it's crates.io, and I'm not sure, but maybe there is on crates.io. There's some status page there where we can see if things are okay. Let's see. Status. Okay. Okay, I stopped the music because I'm downloading music at the same time that I'm downloading the crates. At the same time I'm streaming, and maybe that's the problem. Yeah. But we are almost there, yeah. So there are only 2 crates missing to have this thing installed right now. So let's see. Okay. Is it okay right now? Because I don't know what's happening. Only audio, right? Yeah. I don't know. The problem is that I downloaded a lot of stuff at the same time I was streaming, and looks like my connection could not handle it. And uh, it looks good, but I don't know why it couldn't handle it. And then the frame rate for my streaming slowed down a lot, and now it's getting better slowly. But okay. Yeah. I don't know what to do. Let me check. Now I have the expand installed. I'm not downloading anything, but I think you guys cannot see my screen, right? I don't know if I can restart this stream or if I'm going to miss it. 1 second. I'm trying to resolve it, but we are at the end of the stream. I was just going to test the expand subcommand for cargo. Yeah. Yeah, the problem is my internet connection. Yeah. My internet is bad. Everyone is using internet right now to stream Netflix because of the quarantine, and then all the systems are slowed down more than the usual. Cool. Yeah. But you guys can hear me? Just you can't the the screen is not updating, right? You can have only audio. Or the screen is back. Slowly. Yeah, just saw in my mobile. We lost video and we have only audio. Okay. Anyway, I think I will not be able to show you guys cargo expand. I will try to have it anyway running here. And oh, that's pretty nice. I want to show you what's doing, because it's doing exactly what I wrote in the macro. Yeah. And let me see if in the stream manager for Twitch, if I can do anything to solve the problem. Maybe restart the stream. Actually, I'm not using Twitch directly. I'm using Restream to do the multiple broadcast of this, and maybe it's having problems. I don't know. I see that people are connected in each of those channels, but I can't see the video being streamed there. So looks like I will need to restart the stream, but I don't want to do that because I don't want to do that because yeah, very choppy. It has something to do with the bit rates. I lost the connection, and then the bit rates were very high. Like it was red, now it gets back to the normal. I don't know what to do. Okay, what I'm going to do, people, is I will not try to restart the stream because we are at the end anyway. It's starting to get better. Okay, cool, nice. Yeah, I think it was still downloading something. Yeah, and now it just ended. Maybe. Okay, so this is the output. Let me do it again. So what I did is I entered here in my shell and I run cargo expand, only it, and the cargo expand showed me the actual code that the macros created. And you can see that starting here, it included the preload import, which has nothing to do with the macro. It's something that Rust is including in every program. And this preload import is what gives us access to the primitive types and to result option and all the other things we have in the global namespace. It's imported everything from the v1 to us, and this is the actual code we wrote there. The struct, the derive. Yeah, the deriving is very interesting because you see that for the duration, when we use the derive debug, this is the code it's implemented automatically, and this from is what we wrote. And here all the structs that the macro created for us. It's beautiful. It's a very beautiful code. I was expecting to see some very obfuscated code, but actually it's creating beautiful code and formatted code. Yeah, that's very interesting. Yeah, very cool. So what do you guys think about macros? If you can hear me, I will just delete all the code that I have commented out here. Okay. And let me know, what do you guys think about macros? Do you think macros is something cool to use for this example, like generating structs implementations at pre-compilation time? Or do you think it's best to write everything by hand and have more explicit things? Yeah. There's a huge delay. Yeah. Yeah, I think I would not be able to solve that. It's an internet problem. Yeah. I can't fix it. So sorry for that, but yeah, I may need maybe better internet plan here on my to be doing downloads and streaming at the same time. Yeah, because that all happened when I did the cargo install part. Yeah. Okay, but anyway, we finished here with this macro thing, and I will do exorcism submit again. So I have this second implementation submitted. So I have now 2 iterations there, and as usual I will paste the link for the solution here on the chat. So Nathaniel, if you want, you can just give your feedback there. And if you think there's something else we can improve, I will take what you say, and maybe in the next stream when my internet is better, I will try to implement it. Yeah. We are back. Yeah. It took some time, but now we are back. I was thinking the problem was in the crates.io, but it's not. Okay, folks, I think that's all. Right? We are done. We implemented the space age, and it was very fun. And I learned a lot again about lots of things. I learned about the commands, how to include the tests, how to run the fix command, which I copied to my snippets, how to run the cargo fix directly using nightly. So that was awesome. And we implemented the macro. Yeah, so code looks good in 2 iterations. So thank you so much again, Nathaniel. I will do the complete of the exercise. I'll give you 5 stars. As usual, it was a great mentorship. Thank you so much. And the next exercise is going to be sublist. Yeah, so next week we are back to do sublist exercise, and that's it. This one I never did. I never wrote this one in Python. Oh, I clicked it wrongly. I never implemented sublist in Python, so this is all new. I don't think there is sublist in the Python track. I have to take a look. But looks like we are going to use some vectors, some, I don't know. If are there this approach in another language, you mean the macros? There are macros in another language? Yeah, I think there are. I think Elixir. I don't know if my audio is back in sync right now, but I think Elixir. I wrote it wrongly, but if I'm not wrong, Elixir has macros. Which what more language has macros like this? I think other functional languages like Camel maybe has macros. Maybe we can search for that. Yeah, languages that supports macro expansion. I think it's the term we need to look for. Macro expansion. Macro computer science. There are hygienic macros, procedural macros, synthetic macros. Lots of some languages provide one or another, but we can have some list of languages here somewhere. So C programming language, we can have yeah, parameterized macros. I'm not sure if the attributes in C are macros the same way I just learned it's in Rust. But Lisp has macros. Yeah, I have wrote some macros in Lisp when I was using Emacs. Racket. But if you think about all the mainstream languages today, like for example Python, Go, Ruby, Java, I don't think those languages has something like macros. Yeah. Ruby has code blocks, but I think it's different. Yeah, we don't have a list of languages here. We just have lots of text. I would expect to see a list of programming language names. Why aren't macros included in modern programming languages? Let's see. I know implemented unsafely in C++, in C, blah blah. Find 2.1. Yeah. I don't know. In the